Okay, so we've got a parallel circuit here. All these resistances are going to be the same resistance. Let's say we've got 120 volts, and this first resistor here, say this is 20 ohms. So just do the tower of power for right underneath here. So what would our amperage be in that circuit there? 6 amps in here, 6 amps in here, 120 volts here, and so this next one here, and this is a good time to introduce this. Notice I have a ruler, straight edge, this is the template here. So I'm going to ask you to do drawings and hand them in to me. So it has to be done with a straight edge. I need drawings, not done with a straight edge. You can do the symbols by hand, but it won't be accepted. So you have to.
Pick up that one.
This one here is from my impression.
So they don't.
They just got rid of clay tablets.
They already have this like flimsy one now. I guess it's.
Yeah, that one's pretty good. Yeah, we farther here. So this one here, this has got 6 amps through it also, right? So down here in this tower of power, we're going to be adding the amperages together. So now we've got 12 amps through this circuit. This is not just the branch circuit. This is each one of these is going to be for the whole circuit. Okay. So in this circuit here, our total is 12 amps. We still have 120 volts across the whole thing. We've got 1440 watts. And what is the equivalent amperage now? Or sorry, resistance. 120 divided by 12. You see that? 12 ohms. That's the equivalent. So this one here, this branch here will have 6 amps underneath also. So we have 120 volts. And the total amperage on this whole circuit now will be 18 amps. And so from that, we can find out what the equivalent resistance is. So this time we're not adding resistances, we're adding currents to find out our total resistance, where before we added our total resistances to find our current in series circuit. So we missed some of the sound for the recording, but 6 amps here. We have this all up. We've got 30 amps. 20 volts. I'll get this one for you. 4 ohms. And the total is, what's the total wattage there? So the thing to look at this is as we add more branches, 20 parallel circuit, the amperage goes up. And as we add more branches, the total resistance goes down. And of course, the wattage goes up as we add more branches. If each one of these is 20, notice that the sum of 2 of them is less than 20, and 3 of them is less than 20. So that the resistance of a circuit is always smaller than the smallest resistor. Even though these are all the same, but it's really short. This here is adding amperages, finding your total amperage to find your total resistance. The other way you can do that to find your total resistances is this formula here, where 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Another way to do that is have RT is equal to, put a bracket around this, R1 to the negative 1 plus R2 to the negative 1 plus R3 to the negative 1. Bracket that and put negative 1 to everything there. So that's, let's do three of these together. Adding these up, showing you different ways of doing it. So what I do is I put my bracket in first, and then I could take 20 ohms, second function. Oh, this one is different. One is two. Okay, second function. So there's 20 to the negative 1, or 1 divided by 20. Plus, we have the same one, second function here. 20 to the negative 1 plus 20, second function. Negative 1. Bracket that. So there's 3 of them. And then second function, negative 1 to the whole thing. So that's what this one here is. Hit enter and I got 6.67 or 6.6. Let's say we had, this is another way of looking, let's say we had a 60 ohm. And 2 lines like that is electrically, we say that's in parallel with a 30 ohm in parallel with a 20 ohm. So, so when I look at that, when you look at that, what do you think? Just to do a guesstimate. What do you know it's going to be larger than or smaller than? Smaller than 20. It's going to be smaller than 20. And if it was, when I look at that, if it's 3 60s in a row, it'd actually be 60 divided by 3. And that's one thing I just didn't show you back when we had 3 20s. So if they're all the same, 320 divided by 3 exactly, there's our value. So if they're all the same, you can divide by the number of resistors there are in your RT. So we have 20 divided by 2. So yeah, so one thing you can look at this as well, if there are 3 60s, that would be 20. For 3 20s, it would be 6.7. So it's going to be somewhere between 20 and 6.7. So you kind of know roughly where you're going. So we can put that in our calculator. Bracket 60 second function plus 30 second function plus 20 function. Close the bracket. Put the inversion on that also. Everybody get 10. About 6.67. Of course, if you did any of the review stuff, you say, well, I got 3 resistors in parallel. The RT is 10. I have a 60 ohm and a 30 ohm. What is the third resistor? So how do we do that? So we're going to do, we didn't know what this one here was, so we didn't know that was 20. And we put 10 to negative 1 minus 16 to the minus 1 minus 30 to the 1 to find out what R3 would be. So maybe we should do that one. 10, 1 minus 60, negative 1, 30. So R is equal to 1 over G. So what does G equal to? Write that down. Little algebraic exercise here. And where do you see 1 over r lately? Parallel circuits. So even though I'm assuming most of you recall this parallel law here, 1 over r1 plus 1 over r2 plus 1 over r3. And what you were really doing was talking about conductances. So resistance is something that stops you from moving. Conductance is this the inverse of that. How easily does it flow? And the unit of resistance is what? Ohms. And the unit of conductance is Siemens. You know, maybe you had anybody with Siemens breaker in? So why did they call their company Siemens instead of resistance or ohms? You know, they're like, their whole philosophy was how easily something moves. So you've been using conductances already. G is conductance. And we're going to do, when we get AC, we're going to have a triangle that has conductance on one side, has susceptance on the other side. And the hypotenuse is admittance, it's an admittance triangle. So we're going to be using conductance. I'm just going to add 2 other things to that when we get there. Okay? So really this formula here is G total equals G1 plus G2 plus G3. So even though it's written a bit differently, you've been using this all along. Gotcha. You know what you're using, right? Okay, let's say I want to do one thing here. We did 3 of these in a row here. So what's a good one? So let's say we did a 60 and a 20 in parallel. What is the resistance of 60 and 20 in parallel? So 16 and 20. So the other one, the product sum, is just that sounds. We can take the product of 60 times 20 divided by sum of 60 by 20. So you've got 120 divided by 80? No, 1200. 1200 divided by 80. What is that equal to? The product sum is just going to save you if you've got just 2 of them. You don't have to do it. It's just a little bit easier to do it. Sometimes you can just get the first numbers and the second numbers in your head. Math, and of course the RT of the same number, and just split down as 60 to 60 and 60 would be 60 divided by 3 would be 20 ohms for all 3 of them. So if they're all the same, you can divide them by the number. What do we else we got here? We've got IT. IT equals 1 plus 2 plus 3. Of course, the fancier one is which one we're going to do with minus R1 equals 1 minus 1 plus R2 plus 1, or GT equals G1 plus G2 plus G3. The only one left is the power. Watch total equals P1 plus P2 plus P3. Those are our parallel laws.